Good morning, my name is Amanda, and today I'm going to share with you some comparisons of machine learning techniques for classifying the underground behavior of an ecosystem engineer. Advances in wearable or implantable biologging sensors have really expanded the number of behaviors that can be studied, shifting the focus away from readily observable behaviors or those that rely on animals to be in specific locations or detected by passive scanners to behaviors that are more difficult for human observers to view. And this is allowing our team to begin to quantify the unobservable behavior of California ground squirrels while they're below ground. And to do this, we are deploying collars equipped with accelerometers, which are sensors that are small spring-like type sensors that generate voltage that is proportional to the change in acceleration that an animal is experiencing as it moves through space. And so machine learning techniques are a suite of algorithms that are commonly used for analysis of this type of data because they're really good at extracting patterns and features from large data sets, and accelerometer data sets can easily be upwards of millions of rows. And so here our goal is to use machine learning algorithms to take the accelerometer data, which looks a lot like what's seen here in red, and tell us what the squirrel is doing. So translate those graphs to an actual behavior, like we see here, like the squirrel is sitting. And to do this, we used supervised machine learning algorithms. So if our goal here is to take this raw data and feed it into our model and have the algorithm tell us a prediction of the corresponding behavior, the supervised machine learning algorithm requires us to first train it with data that has already been paired. So ground truth data where there is accelerometer reading, and then an observer who saw the squirrel and its behavior, and feeding that to the algorithm to train it how to read the accelerometer data and label behavior. So in order to get that paired training data, we conducted 13 focal animal surveys on 8 different squirrels. So we collared individuals, released them into the environment, and then an observer followed that individual and using a voice recorder spoke each behavioral change that was observed using a predetermined ethogram. So we could then use JWatcher and our statistical software to take those focals that were observed by a researcher and pair them with the data collected by the caller at the exact same time. This data was collected at Briones Regional Park on a long-term study population that's managed by Jennifer E. Smith. And squirrels on this site are marked with temporary fur dye, and this helps for recognizing individuals while they are out in the environment. And here we deployed collars on 8 different squirrels and conducted 13 focal surveys. And it's possible to train the machine learning algorithms to detect and recognize patterns and behaviors because each behavior performed by an animal has a specific motion signature. So in this figure taken from data collected during one of the focal follows really illustrates that point. So here we see how auto grooming and walking really look different from one another. So there is variation within the behavior, within each behavior, but they're more clumped with their own behavior. And there are many types of machine learning algorithms. Here we use 3 commonly used types for the classification of behavior. So starting with k nearest neighbor, which measures distances between data points to its k nearest closest neighbors and creates clusters and labels from that. We also have decision trees, which rely on a set of rules or heuristics to answer a set of yes or no questions until the most appropriate behavior is selected. And then there are also artificial networks, which are a set of algorithms all on their own that also include deep learning algorithms. And in a general sense, they all use layers and connected nodes that are loosely modeled off of our neurons that help pass and transmit information to other layers depending on reaching value thresholds. And so currently we have run our KNN model, and it is predicting behaviors from trained data correctly about 80% of the time. And we hope in the coming months, we will have our decision tree and neural network up and running as well. And so once all our algorithms are performing well on the training data, we can then move to feeding the algorithms unsupervised data. So data collected by the caller while the squirrels were known to be underground. And during the focal surveys, each one of our individuals did go underground for some amount of time. So we were able to isolate those bouts of underground behavior, and we can use that as our unsupervised data. So with our 8 squirrels, we collected about 183 individual bouts of going underground. This added up to 16 total hours of underground behavior, and each bout on average was 5 minutes. And right now we're still working on the training phase of our algorithms, but once all of these are predicting the trained behaviors or the paired above ground behaviors at a high rate, the plan is to then take those isolated underground bouts, give them to the algorithms, and the algorithm will provide us with something like this hypothetical labeled graph here, where if this was an underground bout, it would then overlay what it predicts the animal was doing while it was underground. Thank you for tuning in. If you don't get your questions answered today, feel free to reach out to me by email